All right. Here.
Well, and I've had my schedule rearranged 3 times today. And so I've got somebody coming at 2:30. I was like, they were coming at 11, then they were coming at 12:30. Then I had a presentation to go to at noon, and then it got moved to 9. I'm kind of like, oh Lord. So today's been a disaster. But, and I couldn't agree more, I guess, with what Dr. Grubb was saying about the teams. You know, what's the best team I've been on? You know, I'm thinking best project. Yeah, I'm thinking from my perspective, teamwork, the team, and the communication. In fact, I'm on one of the best ones that I've ever been on right now. And I was noticing that, for example, the project manager has a conference call scheduled every Friday at 11. And you know, some weeks you don't have much to say. And but he never cancels it. And at first you would say, well, that's annoying, but it's not, because when he doesn't have much to say, we still have the conference call at 11, and he'll get on and say, well, I don't have a lot to say, and I respect your time, so let's try to keep this to 10 minutes. And it's okay, because you know, Friday at 11, we're going to talk about this project, and I need to have my questions or things ready to go. And so, you know, it's that thing he was talking about, that over communication, which I don't think that's a bad thing, you know. And so anyway, that's good. And the other thing that I was going to follow up on your comment on the NSA thing and the random number, I looked it up a little bit. It does appear that they left a back door in there. And it seemed to me like the only fallout I could find was that somebody else exploited it other than us. It was part of what was called, I guess, onus. It was called an onus policy, only us. It was supposed to be that only we could exploit this thing, and apparently somebody else did. so that's in and of itself a fallout. It was probably unintended.
Makes people distrust NIST.
Yes, it does. Yeah. But that was an interesting question. So anyway, why you move down much? Yeah. So one of the things that I got to start. I got to leave at 2:15. We're ready. Yeah. Well, you guys want to get in here? I know. I thought I'd have a little extra time. But one of the other things I read right before this semester started was that it appears that students, I guess, have almost, it was a study, 30-some% increase in learning if they have a clearly defined set of goals. And so I thought, well, we do kind of have goals for the whole course overall. That's, you know, the syllabus, and I say, you know, we want to learn these things. And I realized, well, yeah, that's broad. And I do try to put an outline every time of where I'm going. But I thought, well, I'll also try to include a set of goals every time. So for today, if we did have a chapter that I have to leave early on, this is it. I mean, it's basically, this chapter is making tables, you know, and graphs. So I'm assuming everybody can do that. But there are what I would consider 4 good takeaways from this little short lecture that you may have thought of or may not have thought of. So I wrote them up here. So one is we're going to look at what's called a contingency table, and that will be say you had a categorical variable, so you counted how much percentage falls in a particular category. You'll see when we do examples, and there's different ways to slice it. You know, you could base it on the total number of readings you had, or on the row total, or the column total, and that'll allow you to reach different conclusions. So you may have never thought of that. It's not like it's, wow, this is amazing. But you just may have never looked at the box that way, and so thinking about it, looking at it that way may help. The other thing is they make a point about stacked data in a table, and I had never really thought about that, you know, because I'm such an engineer that if I have a table and I've got a bunch of numbers, you know, X versus Y, and for condition A and X versus Y for condition B, well, that's 2 tables, right? Or a 3D table or something like that. Well, you can't just stack them all up, and you'll see the example. And then there are advantages to doing that for some pieces of software and data processing algorithms. So just, not that it's a big deal, it's just learn what they mean by stacked data and realize there may be a time when you want to do a table that way, and it may help you just think about it. So again, these are thinking things. we talk about histogram because the point of this chapter is some data display. And the biggest thing I want you to remember on a histogram is that it's a nice way to know what your distribution looks like. And why is that important? Because you make a lot of statistics assumptions based on the distribution. Is it a normal distribution? Well, if it's not, you're going down the wrong path in a hurry, or you may need to build a model, and you may need to have some distribution to calculate something like arrival time or number of errors or something. And well, you don't want to use a normal distribution if the darn thing doesn't look like it. And you can easily build a histogram. That's one of our examples I'll show you today. And then finally, the last little bit of the view graphs talk about pivot tables in Excel. I have never had the opportunity to use pivot tables because I don't think my data sets are all that big. I was trying to think, why am I never use these things? But I know how to do them, and I've got you an example in there. They're kind of cool, and I don't know if anybody else ever used them. I thought they were kind of interesting.
And we use them for looking at how many hours everybody in the divisions worked on what charge codes, and then it'll spit you out a list by charge code, by month.
Person, right. And that's what it'll do. Let you slice and dice your data differently. Yeah. And see, you're talking about a whole division. And see, I think most of the data sets I've dealt with have been, tiny enough that, well, why do I want to, slice it different ways? I can see the whole darn table on one sheet. So that's why I never had an opportunity, I think, to use them. But good heavens, they're easy to use. I've got an example for you. If you ever want to make an Excel with pivot tables in it, well, you can see my example, it'll take you 5 minutes, and then you're good to go. And so we'll talk about them, even though I don't use them. You may never, but it's one of those good examples. So this is just a simple, short chapter, like I said, tables and data distribution. So if I had to pick one I had to leave earlier, this is a good one. So we'll go right through it quickly, and you'll see. So yeah, we're going to learn tables, charts, ways to present, and also some good examples on how not to present. Some chart junk is what they call it. So we're going to divide it up in the table world. It's not on the screen, is it? Is that good enough? It's just the aiming, isn't it?
We can see.
Yeah, it's just I thought first it was that. So it's you may just have one variable, one categorical variable, and then you'll just put in a summary table. Hey, that's what you've always done. Or two categorical variables where you call it a contingency table. That just means you've got one variable is the rows, one is the columns. Like A and B and cost 1 and cost 2 or something like that. We'll see a bunch of examples. I could have done that, right? That's the mechanical thing.
It makes it easy. It makes it look easy.
Exactly. So here's a summary table, right? Okay, I've got one thing I'm looking at, one variable. How do you like to bank? There it is. And then you can think, well, we can show this a million different ways, right? I mean, you've done this kind of thing a bunch of times, I think. And you might use it to study patterns. You might use it to look at different percentages. You got just the tally for but if you got two variables like this one's saying, then now it's like putting two tables into one, right? You've got one row that's one condition, the next row is another condition, maybe the third row is even a third condition, etc. And you can envision, 3D tables and things like that. Sometimes I've done that. It gets harder to see when you get more than one variable. So for example here, contingency table. And also, hey, we're in the observe, if you can see that. So we're looking at some invoices. We're seeing, are they big invoices or large invoices or medium, and do they have mistakes? And so this is what you call a contingency table, and here it is, just laid out with the raw data, right? Just raw numbers. So now what the point they're going to make, and what point number one is you could balance this a bunch of ways. We can divide by the total number and get one set of percentages or ratio, whichever you want. We can divide by the row total, make one conclusion, or we can divide by the column total. It's still the same data. It's just how are you slicing it and looking at it. It might help you make a different conclusion. Let's see. So hey, if we divided it by the total and turned it into percent, you'll see the 100% sits down here. And so maybe you make some conclusion like they do over here in the corner. 84% of the total invoices have no errors, right? So we're making a conclusion about the total, or 47.5% of the small ones of the invoices are small. Okay. So we're making conclusions about the whole thing. But maybe you might want to slice it by rows. Okay, so here they're getting the total, they're treating each row as an individual, if you will. So now you can see these percentages are based on the total row. Yeah, like the 89 is 170 over 90. So now if we're going to make conclusions, you know, we want to make conclusions recognizing that we normalized or whatever by that value. So let's see, yeah. So now we're going to make conclusions based on the row. So we'll say, oh, look, like they're saying, I guess, medium invoices have a larger chance of having errors than the small. Yeah. So it's easy when you look at it, slicing it this way, to make a conclusion about this on the rows, about information put in the rows. And then if you sliced it by columns, which we'll do the next time, yeah. Okay, so now you can see we're dividing each of these by the column number. That's why the 100% are down here. Yeah, so 50 and 170 divided by 335. Yeah. So now we're going to make conclusions about errors and this, you know, who has what kind of errors. So like they're saying, whoa, there's a 61.5% chance that an invoice with an error is a medium size. So, you know, contrast that with the last slide, we were making a decision or a conclusion about the rows, about the size. Here we're making a conclusion or decision about the errors, and the two back, we were making conclusions or decisions about the total. So, you know, it's not, I mean, that's not a startling mathematical revelation. It's just, you know, I mean, before I kind of looked at this years ago, I'd probably done that, but never really thought about, well, yeah, if you divide it this way, you can make this conclusion, you divide it that way. I hadn't really put that into formal thinking, so you know, it's just a way to think about it. It's like, again, it's not startling, it's just a different way to slice and dice the table. So the next thing they're kind of talking about is here, really, how do you organize numerical data so you can, you know, put it in an ordered array. You can look at a frequency distribution like a histogram, or you can look at the cumulative distribution. They'll do that in the future. We'll do that so we can come up with these distributions and decisions about the probability and where you fall in distribution. But that's for the future. But at least you know why they've done things like that way. So let's see. Yeah, here's where we're talking about the stack format. The thing to define the difference between stacked and unstacked is probably easiest shown with the next view graph. Let me just do it. Let's see. Well, I'll let you keep. I'll give you a minute to stay on this one in case you're writing something on it. What they're saying is, you can either, if you've got say I've got numerical data, you know, temperature versus time or something like that, and then I've got a categorical data, for example, day and night. Okay. Well, I could make the day table, temperature versus time, and the night table, temperature versus time, or something like that. Or I could put them all in one table where the second column is the flag that says day or night. So what difference does that make? Well, you know, it makes the table it looks different, right? I guess here, these are age of students and whether they're day or night student. That's interesting that I chose day or night, probably just remembering. You got the age of students here, day and night, day and night. And like I said earlier, my engineering brain would normally make two tables, a day table and a night table. Okay, there's not a thing wrong with that. But here's a way to put it all in one table. Oh, okay. Why would you do that? Well, maybe you're using MATLAB. MATLAB works really well with nice arrays and matrices and stuff, and you'd like to have it all in one big matrix. This has the same information, and maybe you want to make decisions on whether it's a day or night student, and it's a whole lot easier to look at, you know, column 2 than it is to try to cross-reference another table or something like that. So the point of this is what they're saying here. Some programs require a stacked format. Okay, well, if it needs that, be aware of that. Or maybe if you're making a little piece of software, a little macro or something to calculate something in Excel or MATLAB or sometime in the future, maybe, you know, your brain might say, well, hey, let me do a stacked format. You know, and there's no reason, you don't have to stop with one categorical variable, right? This could be, the second categorical variable could be male and female, or, you know, commuter, non-commuter. You can continue this. So then it's you know, think about that. That's a whole lot better stacking it that way than it would be having a table for the female, male to males, one not. So this does have some real advantages. So that's just the difference between those two. Just think about that. Again, it's not a big, amazing thing. Here they're just ordered smallest to largest. Okay, shows the range, yeah, min and max, shows the number, kind of shows the distribution, lets you know who falls in and who's an outlier, who's not. I think these are things you would have done anyway. You know, put them in order, think about them. Okay, and you can look at frequency. So that's where you're going to take a set of bins, a set of ranges, and count how many are in there. That's a histogram, right? Why do you do that? Well, it gives you an idea of how they are distributed. Yeah, okay, and so you got things to decide if you're going to do that when you're making a histogram. You got the bins, which are, you know, your ranges you're going to look in. If I'm looking from 0 to 100, am I looking every 10? Am I looking every 20? You know, and some of the guidance I've seen, yeah, here, that's right. You probably want at least 5 bins, but maybe no more than 15. One of the things I've done with this kind of stuff is use the simulation modeling software, and I'll have data, I've had data in the past, and you look at the histogram so that you can decide what sort of distribution to assign to it in the model. And I've had a little bit of challenge with that sometimes when you have very sparse data. You know, you don't have very much data, and if you do 15 classes, your histogram's flat. I haven't done anything, haven't learned anything, but then, you know, you put 2 classes, you got 2 bars, you haven't learned anything either. And so sometimes that's a bit of a challenge, but I would say, yeah, if you can get at least 5 groups so you can get, you know, think about trying to make that mountain, you know, with some rectangles, you better have at least 5 divisions or you're not going to get any slopes on it. Let's see, any other comments on that? I had a thought about it, but yeah, sometimes, you know, when you do a histogram in Excel, and I've got an example on here for you to download, it'll just pick bins for you. I'll show you how to pick them, because half the time I don't like the ones they pick, and so I think it's nice to be able to pick your own widths, and you know how to figure out this. You know, just got the range. You can divide it up into 5 equal if you want. Anyway, so let's see. Yeah, so here's some example data. 20 winter days to get the daily high temperature. So you could order them. You could look at the range. You could do what's it going to show you next? Make a frequency distribution, right? So they're going to take 5 classes. It's nice that the range was pretty much 50. So yeah, they're going to say, let's go by 10s, 10 to 20, 20 to 30, yep. But the midpoint, count observations, assign the classes. They're saying pick the midpoint so that if you're going to make a graph, Excel will do all that stuff for you too. So I don't think this is a hard thing to do. Let's see, yeah. So we've got 3 of them in the 10 to 20, 6 of them in the 20 to 30, 5 in that range. Total adds up to 20. So they're using the midpoint as the class 10 but less than 20. And it's nice, I guess if you're going to put it in tables, to define what you do on the boundaries. You know, just so you know which way does the 20 one go in the lower one or the upper one. You know, just define it. And you notice too, for goodness sakes, be consistent. If the higher number went up, well, it needs to go up every time. So just be consistent with that, or you'll kind of mess up. And wow, could you express it as a percentage? Well, yeah. or a relative frequency, yeah, that's no difference. You guys, I think as where we're at in our education, these kind of things are fairly easy. Ordered array, let's see, what do we do here? You know, we're just ordering them. Oh yeah, and we're getting a cumulative, that's it. Yeah, okay, yeah, I see. And we'll use that in statistics later on, but right now, all that's going to play into is the Pareto chart that they talk about in another minute, where you're just summing up the total. So why use this? Yeah, here we are. It's a visual interpretation of your data. And so it gives you the major characteristics and know where the mean is and how the spread is. And again, why is it important? Well, because remember last week when I made that dumb joke about the 50% of the people are below average. Well, none of them are below average if they're all at the average. That's a dumb distribution, I'll agree. It's a flat distribution, everybody's got the same number, but it's not a normal distribution. And you do need to understand that about your data sometimes. Now, if you don't know, maybe you make that assumption because there are many things that are normally distributed, you know, like noise and things like that. So it's okay, but if you're going to go on forever and use this as a basis for, you know, some scientific decision, you might want to know. It's not that hard to make a histogram if you've got enough data, and you can do it and look at it. Let's see. Some tips to see. Yeah, okay, yeah, as you get more data, your bins don't matter as much. Okay, what they're saying here, yeah, if you rearrange the bins, you may get a little bit different picture, especially if your data set's sparse. That's true, but you know what that says too. Oh, is it a normal distribution or a log normal distribution? There's not a lot of difference if the parameters are close. So, I wouldn't get bent out of shape about that if you were doing something like that. I didn't. Yeah, if you're comparing two or more groups of different sample sizes, and this should show up later on in the things not to do in graphs, yeah, you need to use a relative frequency or a percentage, not a total number, if you're trying to make a decision like that. And you'll see, yeah, of course, it doesn't make any sense. So now we're going to do bar charts, which I think everybody's seen. Bar charts, pie charts, Pareto chart you might not have seen, or side-by-side bar charts. So the Pareto chart I got introduced to when Dennis Ruddy was the director of Y12, because he loved them. And then somebody said something about Pareto charts, and I heard what's the Pareto chart? I know graphs. I've done lots of math, and so I had to find out. So I wouldn't be an idiot in a meeting when somebody said make a Pareto chart, and I didn't know. So if you don't know, now you'll know when we get done. So bar charts, we've all seen them. They don't have to run this way. They can run that way. And they can make them ugly. I've got a nice little website shows you some really bad bar charts. Same with pie charts. We've all seen them. You can see some bad ones. This is a pretty good one, but sometimes you'll see 58%, 42%. Oh, I'm glad you did a pie chart on that. but at least there's some visualness to it, and sometimes these little tiny slices get pretty tiny, and you got about 50 of them, and sometimes they're hard to see and things like that. Yeah, think about that if you decide to. Don't just throw a pie chart out there if it doesn't make any sense, I guess is what I'm saying. Or the colors are goofy, like, yeah, hey, this is terrible. Yeah, the colors are better on here, but yeah, you can't even tell the difference between these two. But, so here we go with the Pareto chart. So all I think of as a Pareto chart is a bar chart where you organize things from the biggest to the littlest. And why'd you do that? So you know what the biggest one was. Okay. So it separates the vital few from the trivial many, is what they're saying. So here was the banking data that we looked at. So if you want to quickly know what do most people prefer, it's in person at the branch. Why? Because it comes up first, it's the tallest. You got a nice ranking based on size. And this little graph part here is the cumulative. So of course it's always going to be starting here, there, and it's going to go up. Now, part of the thing I don't like about a Pareto chart is if you got lots of categories, and so here that's 40%, but I got lots of categories, I got 10 categories, maybe everything's going to be kind of around 10%. Then these little bars are teeny weeny, because this cumulative always has to go up to 100 unless you try to rescale, which you can do that too, but then it doesn't look right, and so yeah, it's kind of like I'm more of a fan of just a bar chart or a cumulative chart, one or the other. I don't necessarily like to put them all together, and sorting them's fine if you want to.
For Pareto, aren't you supposed to use the 80-20 rule?
Where
80% of the.
all the things are important, or
Yeah, so that the problems are up here, and then everything,
Yes.
all the little things you can just.
so like you would say, like draw the line here.
And
Yeah.
then all those little things you would just put in other. Or,
Right, and so that's a good point. So so what she's saying is, if you see these are the 80% that you want to look at, or the 20% that you want to look at are the important ones up front. I guess it's 80% is the important ones, and the 20% is or is it the other way around? 20% of the important ones.
percent of the problems are caused by 20% of the category.
Right, yeah, so the 20% is what you want to look at in the front end, the things that are most important, and the 80% is just kind of other and junk, yeah. So, yeah, 80% of the problems are caused by the front 20, the highest 20% of the things. That's the idea it's trying to show. This doesn't show much because it's, with banking preferences, so yeah. It's an all right way to look at things. But, let's see. So here what they're doing is making a bar chart showing, stacked bars beside each other. So here they've split it up with the columns. So this is the error data, and here's the no error data. So you're trying to show real quick that, yeah, the medium ones had the most errors. If you had an error, it was most likely to be a medium one. If you didn't have an error, well, it's most likely to be a small one, right? I'm sorry, yeah, no errors, yeah, column, right. So, yeah, in wizard the errors will most likely be medium. Just, okay. All right, so now if we go over here, now we've got numerical data, that was categorical data, so either we can do an ordered array or stem and leaf, a histogram, or a polygon or OGI, which we've already done that. That's really that line on the Pareto chart. But so stem and leaf, in my mind, which is what they're going to talk about next, is basically a histogram, you know, by hand. And the only thing is, it does have a tiny bit more information because you do have the last digits. You remember stem and leaf? I always forget them. And the only reason I remember is when my kids go through school. You know, they come in, they're like, "Dad, we got to do stem and leaf." What's a stem and leaf like? I don't remember. It's just, I don't ever use them. You know, we don't with Excel and stuff. Remember, you got, here it is. Here's the day and night student stuff. So your stem is the tens digit, and your leaves are the one digits. So see, there's the 16, there's the 17, 17, 18, 18. And the reason you keep repeating is so it grows big like a histogram. So in my mind, it's a way to make a histogram by hand, you know. But you get a tiny bit more information in a histogram. You know, histogram, we would have had just an 8 here, right? Eight things in the 10 to 20 world. So we would have just had an 8. So at least we've got an idea too what values they were. But it has a little bit more. But yeah, so there's the stem and leaf for the day students. Here's the stem and leaf for the night students. Yeah, so you know, you look at it right away and you're seeing, yeah, what you could conclude real quick, yeah, more of the day students are younger. Few more of the night students are older, but not really significantly. But there's fewer of them too. Yeah, so that's interesting. So anyway, I'm never amazed at the stem and leaf. It's just something to remember. But it's a histogram in a sense. That's why they talk about histogram next. And we've already talked about that. So a histogram, you just look and count the number that's in a particular bin or frequency range. I mean, a value range. So the vertical axis can be frequency, relative frequency, or percentage, whichever you want. The class boundaries are the bins. And you just glue them. Yeah, there are no gaps between the bars. You glue them together. So if you try to make it straight in Excel without using the histogram tool, you might have a hard time because it won't glue them together, you know, like that. So, you know, here, this is the 10, this is the, in here, 15 is the 10 to 20 range, right? Let's see. Yeah, here, that's shown here, right? Because it's putting it at the midpoint, 10. And that's a 20, and then 6, yeah, that's the 20 to 30. Yeah, so that's how it's laid out. Now you can see quickly that, you know, maybe you conclude this is you know, a log normal distribution, you know, because it's kind of rated this way. That's good normal distribution on it too, yeah, you know, a lot of these statistical fitting software, these tools that come with your modeling softwares will do it for you. You can feed them the data, it'll automatically give you histogram, it'll give you distribution, and it'll give you the parameters. So if you need to do that, there's all kinds of little tools that'll do that for you very simply. StatFit is one of them. So the percentage polygon is, it's just a plot of the histogram, just using the midpoint of the bin. So like we had the histogram there, we had 3 and then 6, well, you put that point at the midpoint. And then the cumulative percentage, the OGIV is the, well, you saw the Pareto. You just add them up and get to 100%. So for example, here, so here's the ages. So here they're just plotting them. We didn't have any in the, you know, the young age, the 0 to 10. We had 3 in the 10 to 20. We had 6 in the 20 to 30. So you just, it's the very same thing as the histogram. It's just a plot. And you can see they're putting these points at the midpoint, 15, 25, 35, which is the midpoint of your bin. So yeah, percentage polygon, right? You do percentage on the y-axis, and then this one just does the cumulative. So that's, like I said, what you would have seen on a Pareto, except the only difference is they were sorted, biggest to smallest. That's why I didn't start at 0.
Why are they starting at 5 again?
Because they're putting 0 in their data set. You know, even though they don't show it, they've got the 0 to 10. Yeah, which in this kind of plot would make sense because you kind of want it to start at 0. In this other one, I don't think you would have lost anything if you had started it. If you had not had that point in there, I don't think it's like the histogram. You don't have anything there. But I could see in this one where it kind of get confusing if you just sort of started right here. I'd still do it, you know. But I can see where people would like not to do that. All righty, let's see. This is easy. Yeah, scatter plot or time series plot. I think everybody's probably done that. Got some data. Click on the little scatter thing in Excel. You know, you're going to just show the points X versus Y. You know, so yeah, X versus Y. Yeah, so you're looking maybe for a relationship. Is there a relationship? Is there? Isn't? Not. So like here, sales volume versus cost. So you look at that and you say, oh yeah, it looks like there's some sort of relationship between volume or cost and volume. Again, you know, it could be the thing like the silly statistics I showed. Make sure you understand, if you think there's a relationship, make sure you understand why, and if you can, figure out why or what it should be. And be careful when you fit things. You know, if you just click on that and say, give me a trend line, be careful, because, you know, it's going to stick you a trend line through it, and it's going to make a line. It may be a pretty good fit. You can, if you play with the R squared, the fit correlation, you can have some pretty crappy data that gets some pretty decent looking fits. So if you're going to go fling this out and say this is linear or this is a polynomial or whatever, just have some background as to why you think that's true. Or if you don't have any background at all, state that. Well, I don't have any clue, but a polynomial sure fits it pretty good. But make sure you define the range too. So for goodness sakes, if you got a little bit of data and, you know, range from 20 to 60 like you do here, and you fit this to a cubic or fifth order, it might look really beautiful here, and about 2% out here it goes straight to pot. Because, you know, think about it, you're trying to fit, you know, you've got a bunch of data that kind of looks like this, and you're trying to fit a fifth order polynomial to it, it's going to look like that. Well, it's great in here, it's great, and it's terrible out here probably. And so if you do something like that, that's fine. Just tell everybody, hey, for goodness sakes, only use it in this range. And that's okay. You don't, because if you don't, the first thing somebody's going to do is they're going to take your equation, they're going to run off next week, they're going to calculate it down here, and then they're going to use that number, and they're going to say, well, you gave me that fit. Yeah, but I didn't know it. You were going to use it over there. And so that's kind of the things, you know, be careful with that. People do that sort of stuff all the time. Yeah. Time series, okay, yeah, that just means the x-axis is time. Right? Yeah. Why? Because, well, you want to see the variation in time. Because you think time is important. Okay, that's good. It's almost always important. These last few slides are kind of humorous because they're trying to tell you, be careful with your charts. Don't put garbage on them. And we know, we see this all the time on the news. We see it in the newspaper, you know, giant pictures, goofy, creative ways. Hey, just stick with the regular charts, especially us in our world. Why should you put a bunch of images and give you things like that? So here they're giving you examples of dumb things. You know, here's the minimum wage. One of the things they point out, these don't really show a whole lot, any much more than that. And two, when you put icons and things like that on it, so they can print out, is this one 3 times bigger than that one? Well, 3.8 times bigger? Well, I don't know. How do you perceive bigness? To me, it's maybe perhaps area when it's a thing, you know. And so, well, I don't know. Is it 3? It just doesn't show anything. And then these little pictures just don't show anything. So heck with it. Just do this, you know. Well, what's wrong with that? How bad is that? And I understand you're trying to sell USA Today, you know. And so here's another bad one. This is the one they alluded to earlier. A's received by students, and they got a frequency, but you know, so what? 250 freshmen got A's. How many people were in the class? You know, I don't know, but okay. And that doesn't mean a thing to me. There might have been 10,000 people in the class. That's a pretty dumb class. And there might have been 251. That's a pretty good class then. So put a percentage. Think about what you're trying to send. These are easy points. Yeah, don't scale it badly. Yeah, this is, why do that and you do that unless you're trying to hide things, or unless you're trying to make things. I saw one of the bad things that's from Fox News. They had something that changed. They were trying to point out how bad Obama was or whatever. They basically sliced this thing like this. So it looked really terrible because it was, oh God, this is all huge, but the baseline was, 50 or something. So just don't do that. It's not fair. It's not a good way to present your data. And this one people do all the time. The reason is the next view graph will actually tell you why. Excel will do this to you. It'll fling you an axis that doesn't go to zero. And that's not a good practice. And if you can't do this because, how do you do that in Excel? I don't know. Make a little squiggly line. If you're going to put that in a report or something, just point it out. Hey, the y-axis doesn't start at 0, but make sure you flag it so people know. And here they're saying, well, when you use Excel, be careful because it does that to you. You can make really cool 3D plots that really don't add much to things. And sometimes, when you do things with 3D plots or unusual charts, pie charts, it's hard to read. Just think about your chart from the perspective of the reader. Yeah, we'll do this. My major professor, when I was getting my PhD, his statement was, and I really liked it. He said, imagine that we're going to take this graph or this chart out of your paper. Because guess what? Everybody's going to do that. They're going to stick it in the Xerox machine, they're going to put the Xerox, and all you have is the graph or the table. You don't have the benefit of the text telling you, this is what this graph means, blah, blah, blah. He said, try if you can to make the graph stand alone. I thought, well, that's a good point. So when you've got different series, they're clearly identified. The y-axis and the x-axis clearly identified. Their units are on there, for goodness sakes, please put units on. The title conveys, this is experiment 1 with these conditions. Sometimes if you take that to the extreme, your charts look ridiculous. But if you and some of them doesn't, and if you try to sort of push it that way, it's very helpful. It makes a better table, a better graph. Just imagine it's not in the paper, and somebody's Xeroxing, they're passing it around, and then you'll do a better job on conveying what you need to convey. So the last thing is pivot tables, and I can flip through the slides real quick. It's what they're doing, like you said, they're showing you how to slice your data. So here they've got a bunch of 401k funds, for example. They got them growth versus value type funds. They got low, average, and high risk, and all they're able to do with pivot tables. And I'm going to pull up an example instead to show you how to slice and dice. Look, you got the plus here, and you can open it up, see, and now you can drill down into the growth funds, whether they're large, mid-cap, or small, and you can also choose what shows up here. Let me show you an example and see. So it's a way to have a large data set and to slice it and dice it, looking at different parts of the data set. So let's see, like, here, let me just, this is the last ones anyway, because I don't think, oh yeah, there's slicers in Excel too you can use to slice them. But let me bring one up for you. Bring a couple here in the last few minutes. Let's see, there, it gets me back to I'll tell you what, instead of doing that, let me just turn my back and do it this way. Huh? I do better if I have my track on. So let's see. Let me do a pivot table for you. And I've got these up there. I think they actually worked today. They looked good to me. So let's see. So there's your instructions on the pivot table. Like I said, I always try to give you something in the Excel to give you how to do it, what I did. So very simple. And so here's what the original data that I had looked like. And what did I do? Okay, and I took this, I'll confess, I took this off of some website I found, how to do pivot tables. Is a nice little example, and hey, I like it. So they've got a bunch of orders, this company has done some orders, they're just 200 and some of them, and this is great. It's either a fruit or vegetables, it's got a total amount, and it's going to different places. So this is a stacked table, right? It's all stacked, here's the product, here's the category, that's your day and night type thing. Here's where it wins, and you see, oh, that's good, we stacked it, because now we can do it. Now, when you made a pivot table, you can make it different ways. This is by country. So look at the result. So what it's done is taken all these hundreds of things and put them into their different products. And what is this? This is every country on there. Well, suppose, like you were saying, you don't want to just look at all the countries. Maybe you just want to look at what did we ship to, say, France. Okay. So you just click on that, You say okay, and you notice this little picture, it's hard to tell, changes to a filter because it says it's applied a filter to it. So now you've got this, all it did was take that data and slice it for France. That's pretty nice, pretty useful. You know, especially this 200 and some entries. What if you had 20,000? You know, and you don't want to write something, it's writing some macro already for you to slice it and dice it. And maybe you didn't want to do, maybe you don't want to slice it that way. Maybe you want to slice it this way. Look, here's by country, by product, okay? And you see the category says all, because it's got the apples and bananas and beans. But maybe in my report, I don't care about fruit. You know, I just want, because I'm talking to my vegetable supplier, so I want to just look at the vegetables. Okay, well, we'll look at the vegetables, we'll apply the filter. Okay, so now the table just changed. So it's a quick way to change the table. Not that you couldn't have done that yourself and had an individual table, et cetera. It's just, well, you can pass this to somebody and they can interact with it. And like I said, the instructions for doing it, if you've never done it, you ought to try it. Goodness gracious, it's in the on the insert. Yeah, on the insert tab, it says insert pivot table. Comes with this little wizard. You just drag things into it. It's painless, and then you hit done, it's done. And so I was like, oh, I could do that even. So that's one thing. Let's see, what else did I throw up here for you? Just for your edification, don't say you don't care. Okay, and again, you can download all of these. I got, let's do the histogram here. So this is problem 238 in the back. So I just showed you how to make a histogram. So what this page is, the instructions are a set of the instructions and a screen capture of what it looked like. So you can make a histogram. Histogram is under the data analysis up here, data, the data tab. Yeah, sorry, data tab, data analysis, histogram, and really it's not hard at all. If you need it, you can look. Let's see, this data I think I took out of your book. It's just a bunch of property taxes, and here's where I set up the bins. Okay, so this is me setting, you know, I told you, if you just do histogram, if you just select the data and say, give me a histogram, what you get is this over here. I thought, well, I'll put that in there for you. So you can see why I don't want Excel to just give me the default histogram. You know, look at, I mean, those are weird. Look at the bins, they're kind of weird. I'm like, I don't like that. I don't like that at all. You know, and so the way you set up the bins is like I did there. You define your boundaries there, and then you select them in the bin input, and then there you get a much nicer histogram divided in ways that I would like to see. Now you notice, I see mine doesn't have them all piled together like you're supposed to. Remember how to do that? I don't know. I'm gonna be a stickler for that. I'm like, yeah, I'm happy with that one. That's funny.
What do you mean by bins? I'm not.
The bins are these ranges here.
Oh, okay. The range.
What they call them bins because, you know, they're thinking about distributing them. You know, where are the numbers distributed? So what it says is, you know, between let's see, I think it's between 0 and 500, there were 4 pieces of data, 4 tax rates, and between 500 and 1,000, there were 22 of the tax rates. So it's just counting the number of data points that appear in that range. Okay. And you know what? I can't stand up here now. I can't remember. I'd have to go back and look. If I put 500 in there, I think that means 4 of them are less than 500, and then in the 1,000 number, 22 are between 500 and 1,000. I'd have to actually check it to remember. I don't think it's taken on either side. I think the number I entered is the upper number, and then you would ask me, well, what if one was exactly 500? I think it goes up. If you were going to do these things, why do I not know? And the reason I don't know is because, you know, you use this thing again just to get a shape. What was this? Well, like a log normal. Okay, I'm happy. I'm going to do log normal now. I rarely use it to make a conclusion other than that. So, you know, whether 500 went up or down is not really critical. I just wanted the general shape. That's why I don't know the answer to that. But if you did care, you really want to know, did 500 go in the lower bit or not? I just say make your data set, play with it, and see. And is it? I do believe these are the ones less than 500. These are the ones between 1,000 and 500. I think that's the way it is. So you're saying, yeah. Again, it don't take you 5 minutes to play with it. In fact, we can look at the data set and figure it out ourselves real quick. But the whole point is to show this shape, because, you know, one of the big shapes we care about is this normal distribution. And so if you had a bunch of data and you're saying, hey, I'm going to model it as I'm going to use these statistical conclusions and I think it's normally distributed, then you ought to look at it and just see if it is. Is this normally distributed? No, it's not, because it's got this longer tail. Why? It makes sense, because it's property taxes per capita, I think, or something. So, you know, some people, there's some rich people. This is the way salaries would look too, and stuff like that. And so again, with a distribution like this is why somebody would want to use the median to represent the middle of this data instead of the average, because especially if these were salaries like we've always talked about, you know, you've got some salaries, some CEOs and stuff, and out here your average is going to kind of sit over here, and it's not a good representation of the middle. And so that's the kind of things you want to look at on these. Let's see, and the last thing I got on here, I got a Pareto example in case you just want to know how to do it. And I got an example of 2.8, which is a contingency table. So all I did on problem 2.8 is very similar to one of your homework problems. That's why I put it in there. So it's the same thing like we went through in the view graphs. You got a table of categorical variables. These are people shopping, okay? And did you like shopping or not, and are you male or female? So it's exactly like we had in the handout, you know, in the PowerPoints. And then here I sliced them based on the overall total. Here I'm slicing them based on the row. And then down there, I'm slicing them based on the column, just so you can kind of make different conclusions. I always try to give you at least some sort of help with the problem that looks like when you have homework. So, it's a simple chapter. It should be simple. Like I said, remember this book, it starts out, first 3 or 4 chapters get you rolling. You know, they're not difficult, they're not hard. It's not conceptually hard, so hopefully that gets you started slow in statistics. Well, the whole thing's not all that bad. So anyway, nothing next week, right?
Did y'all look last week in our counterfeit book that some of us had bought? Did the numbers?
It was fine. The pages were not, but the numbers were fine, right?
That's what it looked like.
And if there's not, if somehow 1 or 2 somewhere get goofed up, I'll figure it out, and I'll grade what you worked. I've done that before. Because it does happen, you know, you get down, we get to chapter 5 or something, somebody threw something out, and it's a significant problem.